Welcome to Chapter 5. We're going to focus on infrastructure and some emerging technologies as we move through this chapter. As we think about defining IT infrastructure in and of itself, we think about the service platform perspective, understanding and referring to analyzing the actual services which are enabled by new technology tools. And so, for example, a new PC or tablet might save an employee 1 hour per day in wait time for information, which obviously would be dramatically increasing his or her own value to the firm. And so we again, as we start to think about this infrastructure and the use of technology, we have to think about what benefit, obviously, that it brings to the organization. As we look at figure 5.1, the services of a firm or the services a firm is capable of providing to its customers, suppliers, and employees are a direct function of that IT infrastructure. So ideally, this infrastructure should support the firm's business and information system strategy. New information technologies continue to have a powerful impact on business and IT strategies, as well as the services that can be provided to those customers. The point of this slide is to illustrate the centrality of IT infrastructure and services to the achievement of the firm's success. So ultimately, what the firm delivers to customers, its quality, is a direct function of the power of that infrastructure. For instance, Amazon is routinely cited as the most popular online shopping site. Obviously, I'm sure that all of us, most of us, if not all of us, have used the site, have shopped on Amazon, and it receives high praise from customers for the quality of its service and speed of execution. But there's a reason for that. Amazon has one of the world's largest and well-designed computing infrastructure to provide those services on the back end. So we think about the difference in size, obviously much larger, and computing capacity, so much smaller in early decades of mainframes, from today's computers. And that hopefully will give you a sense of perspective regarding how far the computing industry has gone in 60 plus years. Our modern day mainframes are extremely powerful servers used for our large Fortune 1000 enterprise networks and corporate sites. The mainframe overall is not dead. In other words, it still represents a large revenue stream, for instance, for IBM. Examples of the use of cloud computing would be G Suite, which is Google's suite of software application that rivals Microsoft's Office applications at a fraction of the cost. Many of our organizations have moved to that type of a system. Obviously, we use the G Suite here. Most of corporations do not put their strategic or critical systems in the cloud yet because of lingering concerns about reliability and overall security. This slide shows the portion of figure 5.2 that illustrates the eras of IT infrastructure evolution, which we mentioned in the previous slide. The yellow ring connecting the machines in the client server graphic represents a local area network. Personal computers were standalone systems prior to the development of these local area networks. In a multi-tiered client server network, client requests for service are handled by different levels of servers. And so the distribution of computing power across smaller, less expensive machines enabled by client server computing is in part responsible for the drastic increase in computing power and applications throughout any firm. Prior to small, less expensive server computers, that computing power had to be purchased in large blocks at a significant expense. With client server computing, you can grow your firm's inventory of computers gradually over time to meet the demand that is at that current point in time. Variants of Moore's law include the number of transistors on a chip, which doubles doubles every 18 months. Computer power doubles every 18 months, and the price of computing falls by half every 18 months. And so now, even now, this trend seems to continue, but has slowed to around 2 years with transistors today, about 14 nanometers in size. Packing more than 5 billion transistors into a tiny microprocessor has exponentially increased overall processing power. Processing power in and of itself has increased to more than 250,000 MIPS, about 2.6 billion instructions per second. Packing more transistors into less space has driven dramatic reductions in their cost and in the cost of the products that they populate. And so, what do you think the implications of such drastically reduced costs of computer chips might be in the future? And obviously, this in and of itself will have a connection to concepts such as that digital divide in cloud computing. Nanotubes are tiny tubes about 10,000 times thinner than a human hair. They consist of rolled up sheets of carbon hexagons and have potential use as minuscule wires or in ultra small electronic devices, and are very powerful conductors of electrical current. Can you describe or think of any other applications of this type of technology? For example, perhaps in the medical field? Cloud storage services like Google Drive provide 100 gigabytes of storage for roughly $1.99 per month. There's a significant importance in exponential growth in hard drive capacity, which is that the world is producing an increasing amount of digital information requiring storage each year as well. So, fortunately, the cost of storing that information is decreasing at even a quicker rate. That's significant. And so, this figure displays the number of kilobytes of data that can be stored with $1. The y-axis is greatly compressed to display the doubling effect, and if it were not, the increase from year to year would become increasingly enormous. The cost of communication over the internet and over telephone networks as well has declined exponentially, fueling the explosive growth of communication computing worldwide. And so we think of how close the communication cost per kilobit has come to nearly zero since 1995. What implications does that have for the number of people using the internet? And again, we relate this to the digital divide, and we emphasize that even now, A significant portion of the world lacks access to internet and other services. How can that be? And ultimately, what do we do about it? Oftentimes, it has more to do with the reasons of insufficient infrastructure than it does internet communication costs. As we move through the upcoming slides, we're going to go over each of these components in more detail. And so these are the 7 major components that must be coordinated to provide the firm with a coherent IT infrastructure. Listed here are major technologies and suppliers for each of those components. Take a look at the examples. Take a look at the example companies that appear under each heading. What companies appear repeatedly? How many items that are here are unfamiliar to you? To give you an idea of the size of the market for computer hardware and devices in 2020, not all that long ago, seems like an eternity ago, firms worldwide will spend around $900 billion on computer hardware. And that ranges from mainframes to tablets to smartphones. A lot of different opportunities and possibilities. Microsoft's traditional dominance in PC operating systems, so for instance, Windows and productivity software, which we commonly refer to as Office, often is the most important reason for their success to date. Currently, Microsoft's revenue from cloud services and corporate services are their fastest growing segments. And so, for instance, the implementation of OneDrive with Microsoft. Today, the proliferation of operating systems for smartphones and tablet computers, mostly iOS and Android, are mounting a challenge to Microsoft's dominance, which depends heavily on the continued existence of personal computers on corporate local area networks. So just think about your own organizations and how the existence of personal computers has changed over time. The market for enterprise software applications in 2020 is over $500 billion. Excuse me. These applications are considered to be part of the IT infrastructure. Traditionally, though, large firms were the most prominent users of enterprise software, but firms such as Microsoft have moved into the market of small and medium-sized businesses that can benefit also from that software. I just want to remind you the amount of new information in the world is doubling every 3 years. And so again, driving that need for more efficient data management and storage. Companies worldwide are expected to spend $1.5 trillion for telecommunication services in 2020. So think about where we would be today in very early 2024. The trend since the late 1990s has been to reduce the number of servers by increasing their size and power. Dell, HP Compaq, and IBM have been the beneficiaries of this trend. Multi-core processors, blade servers, virtualization are ways in which server power can be radically increased without increasing the physical footprint of those data centers, although power requirements continue to grow. Web development tools and suites are yet another area where Microsoft is featured prominently. Implementing new infrastructure requires significant changes in business process and procedures, training and education, and software integration. And so this is a task that firms struggle to achieve on their own, which drives the need for consulting and other types of services that are displayed here. Business computing is increasingly moving from PCs and desktops to mobile devices, and managers are increasingly using these to coordinate work and communicate with their employees and customers. Do you have any examples of how you may be using smartphones in your business or even in your own personal work or schoolwork? In the past, IT departments in large firms dictated to their employees what kind of devices they could use both on site and off site while traveling. However, increasingly, employees are now telling the IT department what tools they want and are demanding that IT support those tools. And so we have kind of this time frame of bring your own device to work, for instance. See a lot of that happening in public education as well. Quantum computing is in its infancy, but has the potential to revolutionize computing speeds and power. And then on the other side, virtualization allows organizations to optimize their use of resources in new ways and also take advantage of spare computing power by allowing a single resource to act as multiple resources. On demand or utility computing describes a payment structure in which cost is dependent upon actual computing power used. And so cloud computing, we know, refers to online access to hardware or software and related services that are located and managed remotely. Cloud computing allows organizations to avoid the expenses of maintaining their own hardware and software, thus relying on the cloud instead. And so, have you, as students and or professionals in the workplace, use Google's G Suite or other forms of cloud computing, such as storage devices like iCloud, Google Drive, OneDrive, Dropbox? Are there any other concerns you might have over transferring computer resources to a shared cloud? In cloud computing, hardware and software capabilities are a pool of virtualized resources provided over a network, oftentimes the internet. Businesses and employees have access to applications and IT infrastructure anywhere at any time and on any device. Amazon Web Services, or AWS, is a collection of web services that Amazon provides to users of its cloud platform. AWS is the largest provider of cloud computing services in the United States. Edge computing is needed to provide efficient service to consumers located across the country. It works by reducing the distance between local computers and web resources and sharing the total load across many regional computing facilities. Data centers consume approximately 1.5% of all energy use in the world. Cutting power consumption in data centers has become both a serious business and environmental challenge. Another driver in minimizing the power consumption of computer processors is the proliferation of handheld devices to reduce heat in the devices as well as lengthen time between battery charges. Linux plays a major role in the administration of local area networks. Can you think of any reasons why an open source operating system might be a better choice for network administrators than alternatives that are not open source, such as Microsoft's Windows servers? Java is designed to run on any computing device by use of the Java Virtual Machine. This includes mobile devices such as smartphones. HTML is a markup or formatting tool that creates web pages that all browsers can interpret and display regardless of the type or manufacturer of the computer being used. HTML5 is the latest evolution of HTML. And then we also have Ruby and Python, which are popular programming tools for web applications. Firms are collections of thousands of computer programs and systems built over many, many years. In general, these systems cannot talk with one another, and sharing information among them is very expensive. And so, one way to get to work together is to build software links among them. This is the web services approach. You can compare it to the web. So, any computer with a browser can access billions of web pages and draw down the information or download PDF files that can work on all computers. They have a version of Adobe Acrobat installed. In a business firm, you want a similar environment. Any computer program can get data from any other computer program. Web services ultimately helps to make this possible. Dollar Rent-A-Car uses web services to provide a standard intermediate layer of software to talk to other companies' information systems. Dollar Rent-A-Car can use this set of web services to link to other companies' ISs without having to build a separate link to each firm's systems. So the task Dollar wants to complete, interacting with other companies' information systems, is represented here as a collection of individual services in keeping with the SOA model. Dollar wants to be able to quickly and easily share data with other companies. The series of services provided above are combined to accomplish that task. This slide discusses the trends in software outsourcing and in cloud software services. It's important to remember internal sources for software refers to developing software fully in-house. Most companies today will purchase or may lease software or outsource the development overall. Why do you think that software outsourcing is growing so quickly in popularity? How about offshore outsourcing? And so here, mostly to India and other English-speaking developing countries. What types of software have you used online? Service level agreements, or SLAs, are formal contracts between customers and their service providers that define the specific responsibilities of the provider or the service provider and the service expected by the customer. These are important to establish communication between the two firms and to manage the project efficiently. Spending for software that originated outside the firm, provided by a variety of vendors, has been growing steadily. Recent jump in SaaS, or software as a service, spending within the last several years we see happening. What are the positives and negatives of acquiring software through SaaS model? Some of the positives, well, it allows companies to focus on business issues rather than the technology. And for many companies, software as a service could cut costs. On the negative side, however, it increases the firm's dependency on those external suppliers. What happens if that supplier of SaaS services goes into bankruptcy? What is your backup plan at that point? How can IT be flexible and still make long-term investments in hardware and software? Software as a service, or that concept, may solve some problems, but envision some of the pitfalls of working with an external hardware or software vendor, such as Google or Salesforce.com. What are some nightmare scenarios that companies must guard against? For instance, the vendor fails to make critical applications available when needed, poor customer service, and so on. Or the vendor fails to upgrade equipment in order to save investment monies. What are the ramifications of poor IT governance at a firm? For example, if a company does not clearly define what departments have the responsibility to make their own IT decisions, what could be the consequences? Some potential consequences are data mismanagement, poor communication, and ultimately slower response times to crisis. What type of company should opt to rent as opposed to buying software? Possibly companies with seasonal employees or semi annual workloads. The TCO model is a way of quantifying some of the hidden costs of hardware and software. How great of an impact do competitors' services and investments have on a firm's IT services and infrastructure? Is it wise to rely on those factors alone to determine what kind of services your firm provides? For instance, your competitors may not be the industry's best example of how to develop IT services. In fact, your entire industry might be technological laggards. In this case, it might be better to look at the best practices in other industries which have a reputation for superior IT services or capabilities. There are 6 factors you can use to answer the question: how much should our firm spend on IT infrastructure?